This is lesson 4.4 journal, using tables to compare ratios. I will be able to correctly use ratio to compare ratios and make comparisons for real life situations. Okay, vocabulary for this lesson. Ratio, we learned, was comparing two quantities by division. A rate is a special kind of ratio that uses two different units like miles and hours or dollars and minutes. Unit rate was for exactly one of a unit, so like 50 miles per gallon, that's for 1 gallon. A ratio table is a table set up to compare equivalent ratios, and equivalent ratios are equal to each other in value when simplified. So, let's try this. Mandy's cookie recipe calls for 3 tablespoons of butter for every 2 cups of flour she uses. Eldon's recipe calls for 5 tablespoons of butter for every 3 cups of flour. Which recipe has more butter compared to the flour? Use the ratio tables to explain your reasoning. Alright, so we know that Mandy's recipe takes 3 tablespoons for 2 cups of flour. So what we're going to do is we're just going to fill this out using equivalent ratios. So if we were to double that, so 3 times 2 would be 6 tablespoons of butter. If I times this by 2, she would use 4 cups of flour. If we times this by 3, so 3 times 3, that would be 9 tablespoons of butter for 6 cups of flour. If I add another 3, another 2, or times this by 4, because this would be 4 times bigger, that would be 12 tablespoons of butter and 8 cups of flour. Okay, how are we going to use that to compare to Eldon's? Well, let's fill this out, and then let's see if we see something here that will help us decide which one's going to have more flour to the butter. So, tablespoons, he had 5 tablespoons for every 3 cups of flour. So I'll put a 3 here. So 5 tablespoons of butter, 3 cups of flour. If we go up again, that would be 10 and 6. Add 5 more, that would be 15, or 3 times the original. 3 times this would be 9. Then we'd have 20 and 12. Okay, now how is this going to be useful for us? We need to have somewhere that we have something equal. So right here, I can see this one has 6 cups of flour. I can see this one has 6 cups of flour. So I'm going to circle this ratio. We have something that is the same. Now we're trying to decide which recipe has more butter compared to the flour. So why would I choose this one and this one to compare? Well, if this was written as a fraction, these would have equivalent denominators. Because of that, I can see that this is 9 and this is 10. So which one's going to have more butter for the amount of flour? Okay, it's going to be Eldon's. So let's write that in words. Eldon's has more butter compared to the flour because using equivalent ratios, we can see that with 6 cups of flour, he uses 10 tablespoons of butter and who's the other one? Mandy would use 9. So if I were making a judgment about these cookies, Eldon's would probably be a little tastier, but Mandy's is just a little bit healthier because it uses less butter. So, but that's how you can use ratio tables to compare ratios and understand how one ratio compares to another. All right, let's try this one. Thea is painting her house and ran out of paint. To make the last batch of paint, she used 8 gallons of black paint and 20 gallons of white paint. The paint store only has 15 gallons of white paint. How many gallons of black paint should she buy to mix with the white paint and still have the same ratio so that it matches the other paint in her house? What if they only have 2 gallons of black paint? Okay, let's fill out our ratio table and answer these questions. So we know that she uses 8 for 20 gallons of white paint. So knowing that, we're going to use equivalent ratios. I want to know what I can do if the store only has 10 or 15 gallons of white paint. Well, if I can get this down smaller, I might be able to turn this into 15. But I can't think of something that mathematically easily turns 20 into 15. But I can reduce. So from here to here, I'm going to divide by 4. So up here we are multiplying these. You can divide them down as well. Just think like equivalent fractions. So if I reduce this by 4, 4 goes into 8 2 times. If I divide this by 4, I get 5. So, in other words, for every 5 gallons of white paint, she's going to need 2 gallons of black paint. So if we are after 15 gallons, well, if I want to double this, that would be 10 gallons. 10 gallons of black paint, or white paint. That would mean that would be double here, so we can show this happening here. We're doubling. So 5 times 2 is 10, 2 times 2 is 4. She would need 4 gallons of black paint if she had 10 gallons of white paint. So with that, I can take this and I can times it by 3 to make 15. So 15 gallons of white paint means she's going to need how much black paint? 2 times 3 would be 6. All of those are equivalent ratios. And we use that to figure out 15 gallons of white paint. So she needs 6 gallons of black paint for 15 gallons of white. Now, another question said, what if they only had 2 gallons of black paint? Well, we have that up here. For 2 gallons of black paint, how much white paint does she need? 5. So, for 2 gallons of black paint, she needs 5 gallons of white. All right, let's try this last one. James works at a photography studio. He's in charge of printing the photos. In order for the photos to turn out right, each picture needs to have the same ratio between the width and the height. Their most common printing size is 8 inches by 10 inches. With the width being 8 inches and the height being 10 inches. They have 3 other sizes available with the same ratio. Use the ratio table to determine the other sizes and find the missing dimensions. So, 8 by 10, if we wanted to go to the width being 4, what happened? Okay, that has been divided by 2. So what do I have to do to the height in order to keep that the same? I'm going to divide it by 2 as well. So it needs to have the same ratio, but the dimensions are going to be smaller. So 10 divided by 2 would be 5. Okay, now what can I do to this one or this one to make it 20? You can think from the original. You can also think from this. Because they're equivalent, it doesn't matter which one we mess with. Just pick one that's easy. I'm going to say, well, I can take 5 and I can times it by 4 to turn it to 20. So if I take this, I'm going to have to times it by 4. 4 times 4 would be 16. So 16 inches by 20 inches would be another one. It would just be a bigger one, but then you won't have it too stretched out or anything like that. Okay, what about 20? Which one of these would be easy to turn to 20? I can't turn 8 into 20 easy or 16 into 20, so I'm going to use the 4. So from there, I'm going to take and times that by 5. It's 5 times larger. That means I have to take the same one here and times it by 5. So 5 times 5, that would be 20 by 25 inches. Okay, you can see how we use the same common ratio. We just made a bunch of equivalent fractions here, equivalent ratios. And in the table, it could help us figure it out. Okay, rate yourself on this concept, 0, 1, 2, 3, 4. Take a picture and turn it in on your passport.